So can you move stuff as big as cargo containers without wheels or steel or concrete? Well, so what? We have ports, we have roads and pipelines. No, we only have those where the geography and the economy work together. You might know that cargo containers carry most of everything that we have and that most people live by the ocean. But have you ever seen this many ships offshore, or grain trucks for miles blocking regions, or people working this hard to interact with the world economy? We're not talking about robot Godzilla here. I'm talking about winches and ropes, not wheels and concrete again. So I found these old balloon loggers back in the 70s using big winches to pull cargo ashore. That's a 30,000-pound cargo container that is actually moving a little bit slow. So I wanted to see if we can speed it up. You probably seen the NFL's Skycam. I combined these balloon cranes with this modern robotics and put them together into a huge and fast crane, just using lift and cables. So we tried it. We made a demo that went 60 miles an hour and reached 1,500 feet. Another company made a 75-ton balloon crane. That's a military tank in the air. They also made this weather stability demo. Remember, this is just big, ugly winches on the ground and cables with lift. So pretty simple equipment, but you get really big advantages out of it, especially low integration costs. And versatility matters for the market. So we studied hundreds of markets, from tourism to looking for landmines, ship cranes to agriculture. But how do we make something real? One miracle per project. Start simple. So we started with one dimension. At its simplest, it's just a skydiving elevator, just as an example. Add another line, and you get a payload that curves. You add a loop on the other side, and you get some more two-dimensionality. But when you add a pendulum in the middle, you get a real two-dimensional system that gives you like a vertical triangle-shaped workspace. We're working on this as a camera for the scale of NASCAR and PGA events. But when you add a few more cables to this, you get a logistics system. This is a 3D port where you couldn't build one. Or you could augment an existing port. Ports are hard. There's 60-foot tidal differences in some areas. There's shallow ports. There's shallow water. There's cliffs. There's all sorts of geography problems that cause infrastructure to not happen in places. Disasters are a big deal too. So think big, right? Well, there's no upper limit on how many lifters we can combine into one structure, and there's no limit on how complicated this can get. In cargo handling, the volume lets you add special modules together to make a fast process instead of an A to B batch move. So naturally, I'm an entrepreneur, and I said, strings everywhere. It's compelling, but replacing trucks and lowering the environmental impact in the developing world and so on. But it's really exotic, but we kind of gotten away from the one miracle at a time ethos. So, but big, fast, and crazy, that's where it took a little turn. So I said that to DARPA, big, fast, and crazy. And they said, can you catch a big drone from a small ship? They were breaking airplanes trying to do it. So I sent them a white paper and said, a towed kite array can minimize the aircraft stress. But the big idea was an inverted tail hook and a big flexible structure. And DARPA recently launched this from an autonomous sub-hunting ship that caught drones with a cable structure. So what's the point? Well, these aren't planes, trains, or automobiles. They're another way to consider moving stuff around other than vehicles. So let's think about versatile robots that can solve big problems. Let's think about infrastructure over geography. See you on the bus.